Okay, here's attempt number 2 at the final question number 19, the final review demo series. We're going to graph this function and then find the minimum value. The student who asked this question wanted me to find the vertex using negative b over 2a. I'll do it down here. Negative b over 2a, that's going to be negative b is going to be positive 12 over 2 times a. 2 times 2 is 4. That means the x-coordinate of the vertex is right there at 3. That makes sense so far? Because on yours, you put the vertex on the wrong side. You wanted to change the x from here over to the negative side again when I looked at yours. So that was your first mistake, okay? So then, when we find 3, we have to plug this value back into the function and find out what the y-coordinate of the vertex is. So y is going to be 2 times 3 squared minus 12 times 3, and then plus 14. Let's go through the order of operations and make sure we solve all this stuff correctly. First, do 3 squared, that's 9, so it's 2 times 9. And this is minus 12 times 3 is minus 36 plus 14. So this is 18 minus 36 plus 14. This is negative 18 plus 14, which is equal to negative 4. So the second coordinate of our vertex is right there at 3, negative 4. I screwed this all up. 3, negative 4 is right here. Hope you guys can see that because of my chicken scratch right there. I thought the vertex was up there. My bad. Okay, now we're going to graph this doing the 149 protocol. This is the point you want to pay attention to, especially for the constructive response on the test, doing the 149 protocol. A is equal to 2, right? If I have x and y from the parent function, and if I plug in 1, 2, and 3, what is the resulting y after you square it? Well, it's 149. That's why I call it the 149 protocol. But we have to multiply by a is equal to 2. This is going to change how high up we go. 2 times each of these numbers, it becomes 2, 8, and 18. And you only have to graph 5 total points, so I only have to go up 2 and up 8. Okay? So ordinarily, if I went right 1, does this one go up or down? It goes up. So if I go right 1, ordinarily I would go up 1, but because the a coefficient is 2, I go up 2, and that's how we have a point right there, and then reflected across the axis right there. Did you guys see that? Reflecting across the axis? Everybody's good with that? Here's the axis of symmetry, and this distance is 1, so this distance must also be 1. And then we go to the right 2, and from there I'm going to go up 8. 1, 2, 3, 4, 5, 6, 7, 8. So there, and reflect it. This distance is 2, so this distance must be 2. There's your graph, and that's exactly what I'm looking at, looking for the exact points graphed on the final.